Okay. I'm Anders Johansson, working for VSI. Currently porting ACMS to x86. So this presentation, for any one of you who hope this would be a presentation about ACMS features, it's not really going to be that. It's going to be more around how or the challenges we found porting ACMS and how to solve them. So it's a build on to the Nor's presentation, where he said you should do this, you should do that, and this contains maybe a little bit more, maybe a little bit stranger. Norm said something about, if you do this, you probably have personal problems. Come see me. We need to talk, or something like that. For all the stuff you really should avoid to have in your code. But in the case of ACMS, it has almost everything. So this talk is more of a porting journey than the features of ACMS talk. Is that okay?
Yeah. What happens if we say no?
Oh. And if you say no, then you could leave. Yes. So for those of you who don't know me, this is a bit of my background. I started with VMS in 1985, joined DEC in 1987. I then joined VMS engineering around the year 2000, worked for 10 years until it was all moved to India. Then I went to do banking applications for a number of years, and then I joined my old friend again.
So glad. Yeah, we're very happy.
So some words about the background of ACMS. It's an application that has existed almost as long as VMS. Sometime around 1980 is when we can see the first edits. I think that's correct, Rob.
Correct. Yeah.
And it is a TP monitor. And it's actually an entire infrastructure, almost like a small OS on top of the OS. For application developers who's written their application to ACMS, they would be very, very hard pressed to run their application or modify their application to not use ACMS anymore. We actually tried to wanted to do that at the bank when I was working there, and we decided not to. It has lots of integration into the OS. Lots and lots of integrations. It was done by people who knew VMS extremely well and who knew the facts extremely well back in those days. It has some features which makes it possible for ACMS to map or have many, many terminals attached to one process. Historically, you would have a terminal attached to a process which will run the application. Another terminal attached to another process run the application. ACMS sort of modified that so you could attach many, many terminals to one process. That was in the old days when you had all have green screens. It has integrations with PDMS, FMS, DEC forms, LSE, and so on. It also has integrations and requirements with Oracle products, CDD, which requires RDB, and there's also some stuff around DEC trace, which is built into ACMS. Some of the features ACMS is using in the operating system. It runs in all 4 access modes. There are extensive parts of privileged code running in exec mode and kernel mode, and there are parts running in supervisor mode and a little user mode as well. It's not using all documented interface in the operating system because it was created by people who knew what they could call. Even lots of undocumented interfaces are being used. It has its own threading. Remember, I said there are could be several terminals, many terminals hooked up to one process. And while it's not threading the way we know it today with real concurrency and so on, it still had to be context switching the state of those terminals. So each and every terminal had its own session, which was kind of a threaded thing. ACMS also has its own login facility. It's called ACMS Boot, but if you look inside it, it looks a lot like logging out. It has to be kept in sync with changes in logging out. So once and from time to time, we need to look at the login out facility or the login facility in VMS and pick the changes and see if they are relevant to ACMS and then move them across to ACMS. Logging out creates a CLI when you run it. So when you log into VMS via login out, you create a CLI or map a CLI. And so does this too. It has its own CLI called ACMS Boot C. It's not a CLI like we as users view it, but it's a CLI as the operating system sees it. And it uses interfaces in VMS in very unusual ways. There is something called protected shareable images, which is used. There are many software that are using some parts of it in a non-protected shareable image and some part of it in a protected shareable image. And ACMS, the ACMS guys realized that you could do both in one. So they've done it. And it's unusual and it's been done. And it also hand maps DCL into its address space. Well, I'll come to that a bit later. The code base is 50 plus facilities, around 2,000 source code modules. Created in mostly Bliss, but a few other languages. And it also has a large number of build files. There are a number of build files for every facility. It wouldn't be surprising if it is around 10, counting the DCL command files, the data files, and so on. But there are, let's say, 100 plus build files. And the build files also consist of CDDL, so it requires CDD to build. And TPU files and whatnot. Now, here is one thing. For any of you who create software or write privileged code on VMS, you probably link against OLBs. And some of the content of the OLBs have changed between IS64 and x86. So you have to find which one or which module to include and so on in which library, because it's not exactly a one-to-one between IS64 and x86. I use the command library/list/object /names, and it will show you all the modules in the library, and it will also show all the symbols in the quote. So I did some searching when I modified the thing for optional files. This may be standard, but in some cases on IS64, you linked with a module that was architecture specific for IS64. Then there is an architecture specific module for x86. They may be in the same object library, but you just have to find them and modify the build files. And we had a large number of build files to update. Sometimes we decided to create local stubs for stuff that so you could get a linker warning of symbols it couldn't find. And then when you look that up and figure out that this is something we never use, it's just that it showed up when linking. And then creating a local stub resolving the symbol is the right thing to do, because it's code that never will get used by ACMS. For example, also one example was that when we had warnings around when linking the ACMS boots, the ACMS version will never set any passwords. If you log in as a normal user and your password has expired, then you will be prompted to update it, but that will never happen in the ACMS version. So we had symbol issues resolving in that area, and by creating a stub, just get rid of it, because it will never get used. Here comes another interesting thing. ACMS is purely a 32-bit application. And you see, OpenVMS on x86 has moved code. By default, code will be placed in what we would refer to as a 64-bit address space. So if you create a hello world, and then you run hello world, the code will not be mapped at address around 10,000. That was the usual address. It will be mapped at 80 million, which would be viewed as outside of the old style normal 32-bit address space. And while this may seem as a problem, I think moving the code out of the classic 32-bit address space is all goodness, because it would free up space for things that would otherwise share the address space with the code. These are just a few examples: pthread stacks, 32 bits, allocated heap, and so on. And by the way, if there are any questions, just ask. So this is another thing that when you run an application on x86 and you have your code contains exception handling, you cannot fully rely on the 32-bit signal, which is the default one, because in that, if you're interested in the actual PC, you will only get half of it. So if you have exception handling on x86 and you have any code that is depending on the value of the PC in your exception handling, you need to look at the 64-bit signal array, because there you get the entire PC. In the 32-bit signal array, you just get the lower half of it. So now, even if I said that OpenVMS on x86 runs or puts code in 64-bit address space, you can work around this and force your code to be loaded in the 32-bit address space. You do so by using a linker qualifier. So the linker qualifier by default is putting code in P2 on IS64 or x86. On IS64, it by default put the code in P0. build ACMS and work around its extensive knowledge of 32-bit addressing. We chose to link all of ACMS slash segment attribute equals code equals B0. And moving ACMS, making ACMS 64-bit infrastructure would be a huge work. And ACMS applications. So if you create your own ACMS application, ACMS agents and servers, would need to link them the same way. This is currently a hard requirement.
But a COBOL program run in ACMS context can be linked normally standard, right?
No.
I'm sorry. Well, it's controlled by ACMS, but it's running under bootc. It's running under the ACMS booter.
So if you create an ACMS server program,
yeah,
in COBOL, you would have to link it
with the P0.
Yes. This is not ideal, but making ACMS handle 64-bit addressing,
yeah,
is a rather big fish to fry. ACMS also creates object files. So if you went into Norm's talk and listened to him, and when he said, you shouldn't do this, you shouldn't do this.
We did it.
And in this case, I think ACMS did it the right way. So ACMS creates, or if you create an ACMS server application, so the ACMS server, you define the interfaces and so on in a data file for ACMS. And ACMS then calls your server procedures. And the main module of this application, of this server, is generated by ACMS. So historically, ACMS created an object file. So it had extensive knowledge of the layout of object files and so on. So it built its own object file. But when porting ACMS to IA64, someone made the good choice of saying, we have tools that know how to create object files. One of those tools exists on every system, macro. So instead of creating the object file, it creates a tiny macro file, which it then does a little spawn macro at the end and creates the file. I think that's a wiser choice. And I think that's, in many cases, there are tools which could do what you want to do. And instead of making the hard or doing all the hard stuff yourself, you can have someone else do the hard stuff for you. Like using a compiler instead of creating the object code yourself. So I think this was a wise choice. It would have taken a lot more time to learn how to create x86 object files instead of just relying on the macro compiler. But that choice had already been made, and I'm happy for that. Then ACMS has another thing that John Reagan told me, you should never use bound procedures. No one needs bound procedures except a few compilers. But ACMS does need the bound procedures. Or at least ACMS is implemented using bound procedures. A bound procedure is a routine where the routine itself, or the instance that you call the routine, it carries some kind of context which is outside of the parameters you pass it. For example, ACMS uses LBR output help. So when a user types help on an ACMS screen, you go into help, but it gets input from your terminal, which may be one of dozens of terminals, instead of just the terminal you usually use. So to be able for ACMS to figure out which terminal it should send its output to and get its input from, it uses bound procedures, where the bound procedure value is a session pointer. So if, as an example, you're going to put output takes one parameter, which is message string. But for ACMS, it needs, for this to work, it needs to know the message string and the session handle. So this is, so in ACMS, this was implemented using bound procedures. Oops. Did I go the right or wrong direction?
Slide 3.
So on alpha and IE64, each procedure or each function had a function descriptor of some kind. It was called a procedure descriptor in one architecture and a function descriptor in the other. And the pointer to a function would point to this data structure, which then pointed to the code. On x86, the pointer is only pointing to code. So there is no data structure where you can stuff the bound value in anymore. So to do bound procedures on x86, you would need to generate code on the fly. And this is a description of the generating code. So generating the instructions, in this case, you have to allocate some piece of memory, which then can become executable. You stuff your code. The way I did it, I had a code template. I copied to this area. I then patched in the specific information. That was the easy part. It was just using a compiler, allowing it, or asking it to create the code you wanted, and then copy paste from the instructions listing. But then you also have to create unwind information for the created code. If something further down in the code or further along in the call chain fails, you have to have unwind information, and that was a bit more complicated. Luckily, I had help from Ahmed. So this had to be done in a few places in ACMS to be able to get it to work. You wouldn't be able to have ACMS terminals. You wouldn't be able to have help work in. So you do ACMS/enter into your application, then you type help, and that help would not be able to display. At first, I hoped that that the code using bound procedure descriptor could never be used. So I just commented out or made it crash. So I would notice. But then when I started running ACMS applications, I noticed that the crashes I had put in the code, they appeared. So I said, oh shit, I probably need to do this. ACMS also does an extensive amount of its own call stack walking. It has a huge number of exception handlers. And it does its own call stack walking because it has its own kind of traceback built in. So when things happen, you log it to the SWL log, and that contains the call stack dump, which it does by itself. So it has lots of that too. which is also another one of those that where Norm said, if you do this, you probably have problems. Come see me. Then another interesting thing, at least to me, ACMS, in ACMS you can have an ACMS server being compiled code. You can also have an ACMS server being DCL. So you can have a DCL command procedure as your ACMS server. And ACMS allows you to do so. I initially thought it would do a lib.spawn or something, create a sub-process and run your command procedure, but it does not. It actually acts to DCL as a DCL user. So when you log into ACMS boot creates ACMS boot C, the CLI, which then calls some code to actually map DCL itself. But for those of you who are familiar with the address space, the P0 region is where you historically had your code. And DCL runs in P1, and ACMS decides to, by hand, pull in DCL into its process. And it then sets itself up to behave or act as a DCL user. So it sets itself up to be the input of DCL. So it will feed DCL commands. It will also read all of DCL's output. And it appears to a user. And these parts are likely, I don't know anything else that does this. And this took some time to understand, and it took some time to get it.
And that's because it creates those server processes. You can set a minimum and a maximum number of server processes,
Yeah,
and they continue to live across activations.
Oh yes,
Nice.
One of the reasons it put its own message file in P1 too, so it wouldn't get torn away if the DCL procedure did a directory command or whatever, which would map something in P0 and then it would wipe out P0 when it was done. And all it needs, it has to keep away or outside of that area and so on. And then debugging ACMS itself was interesting. It uses all the undocumented interfaces, and it goes deep into VMS. I use mostly TR print. Thank you, Christian. It's a fantastic tool because it's one of those you can call it from any access mode. It's lightweight. If you call it in different parts of your system, it will contain a timestamp. So it's low overhead. It contains a high precision timestamp, and it's limited to what you can print. It's 128 bytes or something like that, and you cannot use any of the exotic versions of the modifier or the formatting. But it has enough. So if you have certain parts you run and you insert TR prints, then you will get them ordered. So you know what happened and what triggered which and so on. So it's very, very useful. Some debugging we did using Delta or XDelta. The normal user mode debugger is not really useful when debugging ACMS. And some of these things, when we debugged it happened to be code in VMS that no one else had used. So no one else had exercised partly protected shareable images in VMS on x86. So we found a bug. And the same was true for system service dispatching in this context. But in some of the cases, we had to force a system cache. We had to set a breakpoint at a certain location in the system service dispatch code where we knew that it returns an error message, which we didn't understand, and then force the system cache and look at all the data structures. And I would say in that case too, I was lucky enough to have the image activator expert help me. He helped me to find it, and he fixed it. I think that's it. Any questions? Yes.
When you create in the older version, when you create the object file,
Yes.
yeah, then you also create objects in CDD.
No, the object files that are created by ACMS,
Yeah.
they come from data. So some of the content of the object file
Yeah.
comes from the data definitions, the application data definitions
Yes.
you have done, so which are stored in the CDD.
Yes, but is there any CDD available today in x86?
No, there is no CDD available yet.
Oh.
But as Brett explained yesterday, we are looking at something that we can use to handle this situation so that we can, for example, in this case, build application for ACMS. But no, there is no CDD available on x86 yet. I may be able to show you ACMS. It's not very fun, no fancy colors or nothing. Can you please help me just share my I would like to share. So if we go up,
Okay. Yeah.
and then just terminal window on Ishmir. Let's see. What does it say? Yeah. Which one is it?
Oh, yeah.
Okay. Yeah, so they should be in this area. Not trying. Let's see what I'm doing.
Yeah.
What did I do now? Something stupid, I guess.
It's the Bootcamp.
I need to share another window. Well, me being who I am, I can't do that.
See if I should go up there too. She's gonna stay in around. Oh, this.
I'll just create another one.
It's the Legion.
Yes. Okay. Should I make this full screen? No, I didn't do anything. Let's do it again. No, it's done.
We can. Which was?
I can do that.
I'm sure it is. Like,
I memorized them.
Again.
but it's
I'm sorry. I'm
Whatever
not
he
an
will,
expert, but
whatever he will now share.
No, it's actually
it's worse when you don't do it, but-
also you want to get.
okay.
Is it your shape? Cancel each other out.
the biggest issue right now is that I don't see whatever.
Oh, okay.
I have this.
I never need to go there.
Yeah, wow.
I could have known this.
So now, how can we get this, like,
Where? This window.
Yeah.
Which one?
It was there.
Oh, did you see it?
Yeah.
Okay. It's just because I'm running a. Did you see it?
yes.
Okay. Thank you. It's. Does this move around the way it does on my screen? It does not. Good.
Yeah,
It's not shared.
you're not staring at the right window now.
But it's not shared. Whatever you type here is not coming here. So you know that. Can we share like just?
Oh, okay. We could change shared window.
You can share the entire screen, I think. Okay.
Well, this is a really good demo.
Sorry, it's a really good demo, yeah.
That's
Sorry.
what he said, that's what he wanted.
Let's focus.
I
I can probably run it though without seeing.
megabyte system. You can just buy it on the megabyte system and now you don't.
Yeah, you.
That's a problem.
Just use it all.
I wonder if
Complex.
So I'm now going to run the ACMS IVP, which is really no more than a smoke test of several areas of ACMS. But still, it shows that something is working.
It's a pretty good test of the plumbing.
Yeah, that's great.
And I've created a small DCL server procedure to run as part of this, which increments number from 1 to 100. Then does a show system /no proc /full to just show the system, show that what kind of hardware we're running on. Oh, it has this stupid built-in 30-second wait. So here you can see it counts up. So it does a fair number of things it checks. So it, as Rob says, it's a good test of the ACMS plumbing, that it works. And it then shows that we're running on x86. And it then prints out itself, just essentially just tell what command procedure we're running. So this proves that ACMS is running on x86. Any more questions?
How long did it take you to get the port working from day one to day done?
I couldn't say from day one to day done because it's not day done yet. But we have a good portion of it running. So Brett has created a few tiny applications which we are running, and they work just fine. But as I showed you in one of the early slides, it's integrated with TDMS, it's integrated with FMS. Probably no one is using those integrations, but still, there's a lot of code in ACMS which deals with FMS, TDMS, deck forms. Probably some customers are using.
That's the more important one, deck forms.
Yes, but still, there are areas which we have bought in, which we don't quite know that they work well. And it might not matter because probably no one's using them, but we cannot know. So we have a good portion of it running at least. Any more questions? Was any of this useful?
Yes.
Yes.
Thank you very much.
Thanks.